Just a disclaimer before we start, in all models in this video, the hydrogen atoms are the ones that are blue, the oxygen atoms are the ones that are red, and the carbon atoms are the ones that are yellow. Thank you. Hi, my name is Simran Tatla, and this is my video on our project on alcohols versus carboxylic acids. To start off, I'm going to show a clip of the baking soda and vinegar experiment that we were supposed to do. In this experiment, you can see the baking soda being added to the vinegar, and we can observe the solution start to bubble and fizz up like a can of soda. We can also observe the match I lit being put out as the gas from the solution takes effect. This gas is carbon dioxide gas, as a reaction from baking soda and vinegar's chemical equation creates CO2, which is also known as carbon dioxide. Next on this video, I'm going to show the models of my carboxylic acids and alcohols. These are my 3 alcohol models. This one is methanol, the next one is ethanol, and my last one is propanol. And these are my 3 carboxylic acid models. The first one is methanoic acid, the second one is propanoic acid, and the third one is acetic acid. The overall physical properties of alcohol include that alcohols are usually a colorless solution, with some exceptions which have a slightly cloudy clear color. They usually give off a sweet smell, which is pleasant to the human nose. They are highly flammable, and when they are inflamed, they produce a blue flame. Lastly, they don't create any smoke while they burn. The alcohol I chose to go into detail about is methanol. Methanol is a colorless liquid that boils at 64.96 degrees Celsius and solidifies at negative 93.9 degrees Celsius. Methanol has a light smell similar to drinking alcohol, and it's not very strong. Methanol is said to taste like common drinking alcohol, but it's poisonous. Fun fact, it used to be a substitute in illegal alcoholic beverages. It burns with a non-luminous flame and generates poisonous combinations with air. Lastly, it can dissolve fully in water. Methanol does not have any big differences in physical properties in the list of generic physical properties. The only difference is the blue flame it creates when inflamed, and in methanol it is less concentrated in color, like a pale blue flame. The overall chemical properties of alcohol include that most alcohols are acidic in nature and they cannot be consumed. They generally react with metals such as sodium and potassium, and alcohols are made up of a chain of carbon atoms and hydrogen atoms, but in place of the hydrogen atoms, an hydroxide molecule attaches itself, therefore being the main indication of the substance being an alcohol. When alcohols take part in combustion reactions, they generally create carbon dioxide and water. The alcohol I chose to go into detail about is ethanol. It is also a flammable liquid having a boiling point of 78.5 degrees Celsius. Because of its low melting point of negative 114.5, it can be employed as an antifreeze product. Ethanol can react with metals such as sodium to produce sodium ethoxide. Ethanol does not have many different properties than the general chemical properties listed for alcohols, except one huge difference is that ethanol is the only alcohol that is safely consumable. The overall physical properties of carboxylic acids include that they are usually colorless liquids, they don't have a very pleasant smell, they're more disagreeable to the human nose. Carboxylic acids tend to have a bitter or a sour taste, but most are safe to consume. These acids have a high boiling point, which increases with their mass, and carboxylic acids are soluble in water, but as the mass increases, solubility does take longer. The carboxylic acid I chose to go into detail about is acetic acid. Acetic acid is a colorless liquid and has a pungent smell which is disagreeable to the human nose. Acetic acid is easily soluble in water and has a sour taste. Acetic acid does not have any differences in physical properties than the general physical properties listed above. The smell might be the only thing that is a bit different from the average carboxyl acid, but probably not obvious to our noses. The chemical properties of carboxylic acids include that the acidity of carboxylic acids is their primary chemical property. They are often weaker than the well-known mineral acids, but generally more acidic than the organic molecules with the hydroxyl groups. They are weak reactants and do not react with normal metals, and they react with highly reactive metals as they are weaker acids. The carboxylic acid I chose to go into detail about is methanoic acid, also known as formic acid. Formic acid can react with iron at a much higher temperature and is a considerably weak acid. Formic acid does not have any differences in chemical properties than the general chemical properties listed in the previous slide. Next on this video are explanations of why my chosen alcohol and acid have their shapes. The alcohol I chose to explain the shape of is methanol. Looking at the 3D model of methanol, we can see that it would have a tetrahedral shape since the carbon atom has 4 atoms surrounding it. The shape of the molecule basically is summarized by the 3 hydrogen atoms and the 1 oxygen atom surrounding it. In a 3D world, these atoms need the maximum amount of space between each other that is possible because electrons repel each other due to having the same charge. Therefore, the angle between these atoms is around 109 degrees, therefore creating a shape where 2 atoms are on opposite sides of the carbon atom, angled in different directions, and the other 2 are opposite to the first 2. The additional hydrogen atoms connected to the oxygen atom is spaced in the opposite direction than all the other atoms. Overall, all the atoms want the max amount of space they can get, therefore having the shape it does. Since oxygen has a greater electronegativity than hydrogen and carbon, this molecule becomes a polar molecule, meaning the oxygen takes the most space and has the most repelling force towards the hydrogen atoms. The carboxylic acid I chose to explain is acetic acid. Acetic acid has the shape it does because of the amount of atoms inside. As always, atoms want to be the farthest away from each other as possible because electrons repel each other. Therefore, the 3 hydrogen atoms and the 1 carbon atom surrounding the other carbon atom on the left are shaped so the hydrogen atoms all around have 109 degrees in between them. While the carbon atom pushes a bit on each of the hydrogens as it's more electronegative, therefore having more space to itself, while the hydrogens have the same amount of space in between them. Since this molecule has oxygen atoms, they have the highest electronegativity, therefore having a repelling force on the other atoms. Therefore, the 2 oxygen atoms surrounding the carbon on the right have around a little more than 120 degrees between them. The last hydrogen connected to the oxygen is shaped outwards from the rest of the molecule too, because it wants its space without interference, therefore facing away from the other atoms. In the end, because all the atoms want to have the most space possible, the amount of atoms surrounding one are split between the 360 degrees available to them. Also, since oxygen has the most electronegativity than the rest of the atoms, it has the greatest attraction of electrons, therefore making its molecule polar. Thank you for listening, and that's the end of my presentation.